Hi everyone. So today I'll be running week 3 guided study group of Math 140 this semester. And so today we'll be focusing on section 2.3 to 2.5, which is mostly about taking derivative of different functions, but we don't need to go through the step of taking the limit as the definition anymore. But now we're gonna have kind of like a general formula that we're gonna follow from now on to Math 141. And so 2.3 is going to be using formulas instead of the definition of limits. And 2.4 is derivative of trigonometric functions. And 2.5 is a very important rule that will apply for both integral and derivative. So it's very important for both Math 140 and 141, which is the chain rule. And not only that, but when you go through Math 230 or Math 251, if you ever have to take them, it is also very important as well, because it's gonna come to multivariable derivative where you really need to make sure that you take care of all the steps of derivative and not missing any of the small derivative in the big one. And then you're gonna get the 3D, three-dimensional shape or graph correct. And so having said that, I'm gonna go through materials of 2.3. So 2.3 is using formula instead of limits to differentiate common functions. And so here basically is kind of giving you these formulas so that you don't have to use the definition, and so you can shorten the time that you spend on limit. You spend on derivative, which is gonna be really helpful when you come to complex function and you go to like further knowledge of calculus. And so we have derivative with respect to x of a constant. So this is c is a constant, is 0. So basically we're saying if we take derivative of a constant, it's always going to be a constant. It's always going to be 0. Derivative with respect to x of x is 1. Derivative, this is the general formula that I highly recommend remember, is that derivative of with respect to x of x to the n, kind of like a polynomial, is n times x to the n minus 1, with n belong to R, and n is so n belong to R. And so we have derivative of a constant multiply fx, so a scalar multiple of fx is going to be that constant multiply the derivative of fx. So we take kind of like in this step, we take the constant out. If f is differentiable, this is a very important, because if f is not differentiable, we don't even have the term d over dx here. Okay, I'm kind of like already started at 6, but I can briefly go through it again if you want to. But can you please put your PhD ID in? I mean, I should be remember them, but I couldn't. So can you please put it in the chat room for me? So okay. So what I just gone through is some formulas that we use instead of the definition limit to differentiate common functions like polynomial and so on. So I already go through the derivative with respect to x of a constant, which is 0. Derivative with respect to x of x is 1. And derivative of x to the n is n multiply x to the n minus 1. And so this is the formula that I highly recommend remember, because this is very general and you don't need to remember these, to be honest, because a constant is x to the 0, and then x here is just x to the 1 with n equal to 1. So there are multiple ways for we to remember these rules, but this is the shortest way if you want to remember. So this box formula here. And so if you have a scalar multiple of a function, then the derivative of that is going to be that constant multiply the derivative of that function if f is differentiable. And so this is a very important conditions because it makes sure that this term exists. And the same thing if we have a sum or a difference of two functions and we want to take derivative of that, it is going to be equal to the sum of two derivative or the difference of two derivative. So we take them separately. If both of them are differentiable, again, that's a very important function again. And how do we know if they're differentiable? That will come back to what we go through last week. And so we also have the product rule and quotient rule. Product rule is basically saying if you have we want to take derivative of a product of two functions, then it is going to equal derivative of first function multiply second function plus derivative the first function multiply derivative of second function. So I'm gonna come more into these when we do the example, but let's put it there for now. And the same thing, we have that for the quotient rule. And so this is the formula, and so the kind of like the condition for that is g prime is different than 0, or we can put it g different from 0 if both of them are both differentiable. And so that's what we have for the materials. Let's do the example. First example is question 27 of section 2.3 in the book. So it's basically asking us to find the derivative of fy with fy defined here. And so from the first thing we see is that this is a product of two polynomial. So what I'm going to do is that I'm going to use the product rule. It is going. So before that, I'm going to rewrite this term in the form of y to the negative 1 minus 3 times y to the negative 4 multiply y plus 5y cubed. The reason I did this is that I try to put it into the form of a polynomial so that we can use this general formula. Is n x to the n minus 1. And so first product rule is going to be, so product rule is f prime g plus f g prime. So this is going to be, we find derivative of this part multiply y plus 5y cubed plus y to the negative 1 minus 3y to the negative 4 times y plus 5y cubed derivative. And so now we use this rule. So for this, we're going to have negative 1 times y to the negative 2 minus and minus is a plus, plus 12y to the negative 5 multiply y plus 5y cubed plus, now this, we rewrite that, multiply derivative of that. So this is y to the 1. So what I have is n equal to 1. So I have y to the 0, which is going to be 1 plus 15y squared. And so now what we need to do is just we're going to distribute them into one another so that we can kind of like group the one with the same power together and kind of like simplify the expression. So what we have here is that we're going to have negative y to the negative 1 plus 5, actually negative 5y plus 12y to the negative 4 plus 60y to the negative 2 plus y to the negative 1 plus 15y plus negative 3y to the negative 4 and negative 45y to the negative 2. And so this and this cancel out. This and this, we have 15y to the negative 2 plus 10y plus 9y to negative 4. So this is the final answer. And so the lesson here is that first, we identify the form of the function. Is it in the form of a sum, a difference, a product, or a quotient? And then we use the appropriate rule. And so if we see these fractions, the first thing we're also going to do is that we're going to rewrite them in the form that we can use the rule of a polynomial. And so if we don't have any questions for this problem, then I'm going to go to the next example. So example 2 is question 107 of section 2.3. And excuse me. So this one is evaluate limit of x approaching 1 of x to the 1000 minus 1 over x minus 1. Excuse me. So the first step that we're gonna do, I think I kind of like did this example last week, but we're just gonna do it again. And so first we have by definition we have this limit is equal to limit of x approaching 1 of x to the 1000. Sorry. So it's gonna equal to limit of x approaching 1 of x to the 1000 minus 1 to the 1000, because 1 to the 1000 is equal to 1. So what I did is that I just rewrite a function. And so this one, by definition, it is going to equal to f prime of 1 with fx equal x to the 1000. So clearly, from here you can see that it is equal to limit of x approaching 1 f of x minus f of 1 over x minus 1. So this is by definition equal to this one. And so now we already have f of x is x to the 1000, and we want to find f prime of 1. And so what we do is that we're going to use the rule of the d over dx of x to the n, or basically derivative of x to the n is n multiplied x to the n minus 1, with n belong to R. And so we have here f prime of x is 1000 times x to the 999. And so when we plug in 1, because f prime of 1 is basically we plug 1 into the derivative function, into the derivative, so it's going to be 1000. So this is just this is one type of problem that you can be asked in this example. And so the way you're going to do is first you should be able to identify what is the function fx here, and what does this entire phrase of this entire limit equal to. And so most of the time it's going to equal to, by definition, equal to the derivative of that function at a point. But then it's also your job to identify what is that function. And so that's all I have for 2.3. So in 2.4, we learn about derivative of trigonometric functions. And so things that we have to remember are these limit and the derivative of these functions. And so I would say in 140 and 141, in 140 mostly, what you're going to use is this formula, this one, cosine, cotangent, secant, cosecant. So only these 6. But secant and cosecant is kind of rare, because they're kind of like getting into the complicated part where you have to identify like points where you have the function not differentiable and something like that, because then we have secant, tangent, cosecant, cotangent. And remember here, secant is 1 over cosine, and cosecant is 1 over sine. So just want to remind you guys about what these functions are, so that if you ever been asked to identify which point that they're differentiable, or they say, okay, I have this function which is like, say, secant multiply cosecant. When I take derivative of this, where is it not differentiable? So you guys will know what function it is to identify where it's not differentiable, because eventually it's just a fraction over cosine, with the denominator be cosine or sine. So just identify the points where cosine or sine is 0 will help you, give you some hint about where your function is not differentiable. But that's way too complicated. So the limit that we need to take care of is that limit of x approaching 0. Remember, this is 0, not infinity, not pi over 4, not any other number, but it has to be 0. Of sine x over x is 1. Then we have limit of x approaching 0 of cosine x minus 1 over x is also 0. Is 0. And so again, the phrase is 0. And then limit of x approaching 0 of tangent x over x is 1. And so this one is that when we just rewrite sine tangent as sine x over x multiply 1 over cosine. So this is kind of like, if you think about it this way, it is a helpful way for you to remember this limit. And so then we have derivative of sine, cosine, tangent, cotangent, secant, and cosecant that we're gonna use through. And so if you need help, like kind of like an assistant when you're doing the following example, feel free to open the book and put it aside with you, and then go through the problems with me. So example 3 is question 26 of section 2.4. So it's asking us to find equation of a tangent line to that curve at that point. And so first of all, identify what is the equation of the general formula of a tangent line. And you're gonna hear me mention this a lot in this class, because I think a very helpful way to approach a problem is that you started at the first step, a very general step. You always know where to start, and you identify what variable are you missing in that function. And the rest of the problem is that you go find those variables before plugging them in to find the final answer. And so here I'm going to try to identify what I'm missing. So the tangent line function is y equal to f prime of x0. So derivative at that point of the function, multiply x minus x0 plus y0. So x0 and y0 is the coordinate of that point, which we're given here. So the only thing that we're missing is f prime x0. And so this is the function. Y equal to f of x is equal to 3x plus 6 cosine x. What we do is that we're going to find what is the derivative of this function. So we have f prime of x. First of all, this is a sum. So derivative is going to go by phrase. So it's going to be derivative of this term plus derivative of this term. Derivative of 3x, I said by scalar multiple of a function is 3 multiply x. So it's going to be 3 times derivative of x, which is 1. So 3 times 1 is 3. And then 6 cosine of x. Again, I take the 6 out. And derivative of cosine is negative sine x. Remember here, there's a negative. So it's 3 minus 6 sine x. So if I plug in pi over 3, so f prime of pi over 3, because I need to find derivative at that point, is x0. So this is equal to x0 and y0. So here we have 3 minus 6 sine of pi over 3. Sine of pi over 3, another very helpful thing to remember is this unit formula. So we have 1 is the unit formula, so the radius is 1. This axis is cosine and this axis is sine. So when we have pi over 3, this coordinate is going to be sine and this coordinate is going to be cosine. So I'm taking about this coordinate. This is one here. And so you also have a table at the end of the book, I think in the appendix, where you can find the sine and cosine of special angles. We have kind of like a small table for that at the end of one of the pages. I don't remember, but it's at the end of the book. And so you're gonna know that this one is square root of pi over 2. And so I think it is very helpful to remember these special angles because you're gonna meet them a lot in the problems and in the exam. I mean, you can always have the book next to you to refer to those angles, but I think it's very helpful and it doesn't really take that long to remember them. So, and as long as you do enough practice, these numbers just gonna come naturally into our like brain because we like did them a lot and we remember them by instinct. So if you spend some time on it, I think it's very helpful as well. Or you can remember this unit circle as I always did. So this one is going to be 3 minus 6 multiplied square root of 3 over 2, which is going to be 3 minus 3 square root of 3. And so now I'm just going to plug every number in. So tangent is going to equal 3 minus 3 square root of 3 multiply x minus pi over 3 plus pi plus 3. So this is the equation of a tangent line that we need to find. And so if we graph them on the graph, this is the graph of your function. So the red one is 3x plus 6 cosine x, and the blue one is the tangent at that point. So this is the point that we assign at the beginning. And so from here, I also want to introduce you to a very helpful tool that you're gonna find it really helpful in the next section. I think in the materials of exam 2, where you learn all about graphing, the first derivative test, second derivative test, extreme value, inflection point, and concavity, and all that. A very good way for you to check your answer and see like kind of like familiarize yourself with different type of graph is this website. It's desmos.com, where you can just simply like input any kind of function and graph them. Kind of like it's a really good way for you to check your answer, but also a very good way for your like beginners, where you try to know different type of graphs, like how it looks like and all that. So that desmos.com. Then I'm gonna go through example 3 of the section. So find the points on the curve with the tangent is horizontal. So the way is the same thing, but the focus here is a little bit different. So instead of finding the derivative, try to find the slope of the tangent line and construct the line. What you ask here is the focus is only the slope. So when the tangent is horizontal, immediately the first thing come to your mind should be the slope is 0. And what is the slope of a tangent? So the general formula of a tangent line is y equal f prime of x0 multiply x minus x0 plus y0. And so the slope of the tangent is f prime of x0. So basically what we're asking for is that find x0 so that you have f prime of x0 equal to 0 with your fx equal cosine x 2 plus sine x. So what we're going to do here is that we find what is f prime of x and set it equal to 0 to find x. And so this is a quotient. But the first thing you look at it is the quotient. So you got to use the quotient rule. So you have 2 plus sine x squared negative sine x, because it's the derivative of cosine, multiply 2 plus sine x minus derivative of the denominator, which is cosine, because derivative of 2 plus sine x is derivative of each of them individually, and derivative of a constant is 0. So what we all have left is just cosine x. Multiply cosine x again. So what we have now is negative 2 sine x negative sine square x, negative cosine square x over 2 plus sine x squared. So one more thing I want to introduce here besides the kind of practice you guys with this kind of problem is that we have sine square of x plus cosine square of x is equal to 1. And this expression is going to follow you throughout the entire semester. And where do we come from this? It's coming from the unit circle that I mentioned before. Since you have a unit circle with the x coordinate of a point and the y coordinate of a point alternately be cosine x and sine x. So if we take x squared plus y squared, you're going to have this line, which exactly is the radius of a circle, which is just 1. So this is coming from the unit circle that I mentioned before. That's why sometimes when people try to remember kind of value or trick of special angles, they use a unit circle because their sine square plus cosine square is always going to be equal to 1. And so from here, we have substitute this part is just going to be negative sine x minus 1 over 2 plus sine x squared. Now, from here, we have to set f prime of x equal to 0 and find what that x is. So I'm not going to go too deep into solving the equations. I'm just going to try to solve the numerator, find where you have sine x equal to negative 1/2. And so here, one thing that you have to note is that you don't have to worry about the denominator and where your f prime of x is not differentiable because you have sine x always bounded between negative 1 and 1. So when you add 2 on both, the denominator is always going to be positive. So you don't need to worry about that because it's always going to be different from 0. And so when you solve this part, you're going to have x equal to, so I is equal to negative 1. X is going to equal to negative pi over 6 or 7 pi over 6. So that is the final answer. Let me check it again to make sure I got it correctly. So yes, so that is the answer. I think so. It's gonna be easy as long as you identify what exactly do you need to find in the questions. And here we kind of rephrase it in the way that you find x0 so that you have the derivative at that point is 0. And so now we're gonna go to 2.5. 2.5 is where we go to composite function, chain rule, and where you combine that with power rule and quotient rule. And so the composite function is I kind of introduced you to the notation that if you have f with a naught and g of x, is that going to be the function of f out of gx. And then we have the chain rule. So the chain rule is saying if you have g is differentiable at x and f is differentiable at gx, then you have this composite function, f gx is differentiable at x, given by if you have f is f not g and x, or you have f is the outer function of gx, then you have the derivative of that function is going to be f prime of gx multiplied g prime of x. This is very important. I think it looks kind of confusing because it introduced way too many notations, but as long as you go into the example, you can see it's going to be very simple. Then you have power rule combined with chain rule. I think I have a note here for chain rule. So here, another way that we can think about this is that when you have dy over dx is going to equal dy over du multiply du over dx. If you have y is a function y over u and an x inside. So that's another way to think about it. So in this way, it's like kind of easier because this dy over du is y prime with respect to u, multiply u prime with respect to x. And then we have power rule combined with chain rule. So the power rule is the one that we have been using a lot recently. So x to the n is equal n x to the n minus 1. But here, instead of just simply x, now we're going to have u. With u is like any kind of random polynomial. So kind of like the additional thing that you have to multiply here when you ask to find that derivative is that you multiply this du over dx. So or u prime. So that's power rule combined with chain rule. The quotient rule combined with chain rule is that we're kind of like gonna have the same thing when you have, say, f over g prime. When you have f prime g minus g prime f divided by g squared. And so if you have this f is like a composite function, then you're gonna have like f prime with respect to h, multiply h prime with respect to x times g minus g prime multiply f divided by g squared. So kind of like if you have f is a function f outside of hx. So if you have that composite function, that's what you're gonna multiply additionally, is that h prime of x. I'm gonna do the example to make this thing a little bit clearer. So example 5 is question 24 of this section. And so it's find derivative of u as a function of y with u given as this expression. And so first thing, identify this is the power rule combined with chain rule. The different things is that the thing inside is not simply y to the 5th, but the inside here is u to the 5th with u equal to small u equal to y fourth plus 1 over y squared plus 1. So by power rule combined with chain rule, the formula give us is that this is u fifth. So when you take derivative of this, you're gonna have 5u fourth multiply u prime by the power rule. Because n here is equal to 5, so you take that n out, and then you have n minus 1 here. So now you're gonna have y multiply y fourth plus 1 over y squared plus 1 to the 4th. Multiply this entire thing taking derivative. And so u here is a fraction. So now we're going to use quotient rule. So quotient is that we have y squared plus 1 squared. You have, so 4y cubed multiplying y squared plus 1 minus y fourth plus 1 multiply 2y. And so how I'm going to come from this, I think it comes a lot from your practice in 2.4 and 2.3, which I'm not going to go any further because it's going to come a lot on your dedication to this class. What I'm going to try to do in this weekly review session is that I'm trying to introduce you to all kind of possibility of problems, but it's your turn and it's like your choice if you on the time that you want to spend in this class. So if you spend a lot of time on 2.3 and try to do a lot of problems, I think if you try to finish all the suggested problems, you should be able to come at this speed of taking derivative with me. But if not, then I think it's really good for you to like practice a lot in that section first, master it before coming to these sections, because there's nothing as worse as being able to do a lot of things, but nothing as good as like nothing the best. So I think you understand what I mean. And so from here we're gonna have 5 multiply y fourth plus 1 over y squared plus 1, the entire thing to the 4th, and then multiply. So now I'm gonna kind of like try to simplify this fraction. So it's gonna be 2y fifth plus 4y fourth plus 4y third minus 2y divided by y squared plus 1. So if you want to further simplify this expression, you're going to have 5y fourth plus 1 multiply actually 10. And then you have y fifth plus y 2y cubed minus y divided by y squared plus 1 to the 6. So that's my final answer for this problem. And so what you need to know here is that first, looking at this, you identify as a power rule combined with chain rule. So you use that formula. After that, you have to use a quotient rule to find what is what u prime. And the rest of the thing is just simplify the problem and put it into one short expression. And so now we're going to go to example 6 of the questions. So example 6 is asking, kind of like doing a little bit numerically, so to make this session not too boring. So put in some numbers. So if you have h of x is square root of 4 plus 3 fx, where you have f of 1 is 7 and f prime of 1 is 4, find what is h prime of 1. So this is a very intensive use of the derivative of the chain rule. So I would say here we have, again, this is a power rule combined with chain rule. So you have, I will rewrite this expression at 4 plus 3 fx to the half because it's square root. So when I want to take derivative, so I'm going to have h prime of x using chain rule formula. So you have half 4 plus 3 f of x to the negative half, multiply derivative of the thing inside. So 4 plus 3 fx derivative. And this thing is going to equal to half 4 plus 3 f of x to the negative half, because it's half minus 1 is negative half. Multiply this one, we have 4 plus 3 f of x. And so derivative of 4 is 0. So you have this derivative is going to equal to 3 multiply f prime of x. So if you want to find h prime of 1, what we need to find is we have 3 half multiply f prime of 1 multiply 4 plus 3 f of x, f of 1 to the negative half. So we end up having 3 half multiply f prime of 1 is 4. Multiply 4 plus 3 times 7 to the negative half. And so it's going to equal to 6 multiply. Now this one is square 1 over square root of 25. So it's going to be 6 over 5. And so this is my answer for this question. And so this is a strangely asked question, but it based a lot on a solid understanding of the material. And so what we do is that don't panic. Identify the form, and again use the, if we identify as a power rule of chain rule, which I think often is the case in these questions. You won't be asked like very weird question yet, because it's this week is all about like practice 2.3 to 2.5. So it wouldn't be too difficult, but the difficulty level is gonna come up as you go through the next week and then the week after that. So I think it's very important now to practice intensively whatever sections that you are in. Try to master it so that next week you're going to focus on whatever you need to know next week. The materials of every week is going to base upon one another. So kind of like the exam might say, okay, it's not a cumulative test, but the materials is building up on one another. So it's very important to understand previous material. And so again, if you have any questions trying to understand these problems as you go through a video at home, please feel free to email me at hgt5011@phu.edu. I'll be more than happy to answer. But if you don't say anything, I will assume you guys understand it. And so if you don't have any more questions about these problems, I have these practice problems. I think it's just one more problem. It's 81 of section 2.3. And please try to do all suggested problem for these 3 sections. Other than that, thank you for coming today, and I'll see you guys next week.